Good afternoon, everyone.
Afternoon, sir.
Okay, so I am recording this lecture just for your information. Can you see my shared screen?
Yes, sir.
So is this the A or the B class, or all of you combined?
All of us combined.
So combined.
Okay, so then I'm going to start all over because I remember meeting one of the classes last week. So we're done with multisim, and then we have gone through the basics of multisim. I have given you some assignments which you have also done. So I believe by now you are conversant with the usage of multisim, so much so that when you are given any task to perform in multisim, you would be able to do it. So this leads us to our second and third unit, that is Introduction to MATLAB and Simulink. Now, at the end of this course, it is expected that each student would be able to do some basic programming in MATLAB and also do some basic simulations using Simulink models. Okay, so these are the learning objectives or learning outcomes, what we are expected to achieve at the end of this course or this unit. So this is the outline. We would have 4 different areas. The first one will be MATLAB basics. The second one will be visualization and programming. The third one will look at how to solve some basic equations, do curve fitting, and then numerical techniques. Then finally, we'll look at some advanced methods. Now, within this, we would see how to use multisim, okay? So kindly take note of that. Now, to get started with MATLAB, I believe by now you have all been able to install MATLAB, right? Hello?
Yes, sir.
No, sir.
No, no stress.
But I had
Yes,
already
sir.
informed you to get it installed, isn't it? You can just give me thumbs up instead of unmuting yourself. You can use the reactions to communicate. All right, so there are several ways to installing MATLAB. You can get the student version on mathworks.com, but it will require that you have a MathWorks account to be able to use that. You can also use MATLAB online, and then you can also get the full package installed on your computer so you can work offline. Sorry. For those who do not have Microsoft, but they use probably Linux operating system or Macintosh operating system, you can download what we call Octave. Okay, Octave. Now, Octave will allow you the flexibility of using or doing MATLAB programming within on your computer. Okay, so take note of that. All right. Now, if you have been able to install MATLAB, you would see a window like this. And that is basically the interface for MATLAB. You would first of all see the place that is labeled or depicted with the red lines. Let me use the pointer so you can see. So here, what you see here is basically what? The current directory. And it's common for even our normal laptops. When you open any window, it gives you the location where you have your MATLAB file saved, or where you have a certain file saved. Okay. Then, if you want to know the details of the file, that is where you see the details. It will describe the file for you. Then we also have the workspace. What the workspace does is that MATLAB is matrix laboratory. That is the shorthand of MATLAB, or the full meaning of MATLAB. Now, everything we do in MATLAB is represented by a matrix. So this workspace here would always list your matrix, your variables, and everything you are working on at that particular moment in the workspace. The other thing you should take note of is the editor. Now, if you are going to program with MATLAB, or if you are going to write codes with MATLAB, when you are done writing your codes, what happened to them? You would have to save them. So in MATLAB, we call something the script file, or the script. The script is basically a collection of instructions, okay? It's just basically a collection of instructions
Hello, sir. Please, I can't see your screen.
check your phone or your laptop very well. Your internet probably has a slow connection. So the editor is where we type all our instructions, and we call it the script. So anything you want to do in MATLAB, if it is a program that you believe you reuse again or you would need in future, you have to save it, or you have to write it using the editor. Yes, Emmanuel. Emmanuel, your hand is up. Emmanuel Techi, go ahead and ask your question. Emmanuel, we are listening. You are muted. Emmanuel, should I go ahead? Emmanuel. Okay, let's continue. So, within the editor is where we type our instructions. And then from there, we can run the instructions. Now, when you come to the MATLAB window.
Hello, sir. Please, I can't see your
Yes.
screen, your share screen.
Are you the only one who cannot see, or everybody cannot see?
So we can see.
So, Emmanuel, check your internet. I've been calling your name for the past 1 minute. You just responded. So it means your internet is not very good. All right. So most of the codes we'll write within MATLAB, we'll do it within the editor. Okay. Now, when you have written a code and you want to test your input and outputs, you do that within the command window. So assuming you want to give an input to your script file, this is done within the command window. Okay. Assuming you want to test the output of your script file, you do that also within the command window. Now, there are several things you can do also in the menus. You have the home, the plots, the apps, the editor, the publish, the view, etc. So let me take this opportunity to share my entire screen with you, and then I would show you my MATLAB so that you can see how the MATLAB window looks like.
I can't see your screen. I can see your screen.
Hello, sir.
Yes. All right, so now I am sharing my entire screen, and I would soon show you or demonstrate for you using my MATLAB. Sorry for the delay. My laptop is running a lot of things, so it's slow to open MATLAB, but we would get it right away. All right, so this is basically the MATLAB window. And this section that I was showing you earlier is the current directory, which is the same thing you find here. Now you would see this section where you have am.m, linus.m, linus.m. That is what we call the editor. And then this section is what we call the command window. And then you also have the workspace here. Okay. Now, anytime we want to write any MATLAB command, or we want to write a set of instructions in MATLAB and save it as a script file, which we can come back to later on or open, we do that here in the editor. And then we can give inputs to the editor from the command window, as well as check the outputs from the command window. Okay, Desmond.
Sir, please, I downloaded the MATLAB from MathWorks, but I don't know where the editor is. It's only the command.
You mean you are only seeing the command window? Hello?
I don't see at the editor. Yes,
Hello?
please. It's only the command window that I can see. But hello, sir.
Yes, I'm listening.
Hello.
I'm
Hello?
listening.
Yeah, please. Is it only the commands window that I can see, but I can't see the editor?
I'll show you how to open your editor very soon, okay?
Okay.
Now,
thank you.
When you look at the MATLAB, you see there are some menus: home, plots, apps, editor, publish, view. Do you see that?
Yes, sir. Yes, please.
Okay, so where you have editor, when you go to new and you select script, it will open a new editor for you. Okay.
Okay.
So here there is a lot you can do or you can discover on the MATLAB interface. The first interface, which is the menu where you have the home, you see you have new script. When you start a new script, it opens a new editor for you, an unsaved and unlabeled editor. Okay. Now, when you select new, you can create a new script, a new function, an example. You can do a whole lot of things. You can even start a Simulink model from here. When you have MATLAB already saved, when you have written a code and it's already saved on your MATLAB or on your computer, you can use the open section to search for that code and open it. You can also find files. You can use MATLAB to import data. You can import Excel data into MATLAB and process it. Okay. You can create new variables, open variables. You can clear the entire workspace and all that. When you come to plots, you can also use this menu to do different kinds of plotting. And there are some apps also within MATLAB that facilitate the usage of MATLAB very easily. You have the MATLAB coder, where you can code using MATLAB. You can write a C program and embed it into what? MATLAB, okay? So take note of that, but we're not going to go to that yet. And then you have the editor, where you can do a lot of things. This is where you also run any code you have written. You use the run, okay? And then you have the run advanced and then run in sections. Then you also have the publish, where you can also use it to do some other editing, okay? You can convert some of your codes to be written into LaTeX. LaTeX is another way of writing documents. Then you also have the view, okay? So this is basically the MATLAB window. So kindly take note of that. So let's go back to our MATLAB. So we can also do customization within our MATLAB window, okay? Where when you go to home, you look for preferences. And then once you get to preferences, there are several things you can do there. You will see the MATLAB with the various menus, and then you can edit it however you want. You can change the environment to look different, like it looks for mine, where you can have the editor and all that showing at the same time. You can decide to also see just the command window, okay? Then MATLAB as a tool is not only for electrical engineers. It is also used by various disciplines in engineering, as well as other disciplines you can think of, like biology, chemistry, physics, mathematics, economics, accounting, and all that. But limiting it to us, MATLAB has several toolboxes, which for those of you who have installed the MATLAB on your computer, you would notice that during the installation process, you would see a lot of toolboxes, and you'll be asked to select the toolboxes you want. Sometimes, for want of space, you may not install all those toolboxes because it would take a huge space of your hard drive. But some toolboxes we would use, or we normally use, or some examples of the toolboxes are the curve fitting toolbox, computer vision system toolbox, toolbox for image processing, optimization, signal processing. We have the communication toolbox. We have the controls toolbox. We even have the biomedical toolbox. We have several toolboxes within MATLAB that will enable specific functions within the MATLAB software, okay? So that is it about the customization and then the add-ons. So if you have not installed those two boxes yet alongside the software, you can just use the add-ons button here to install any toolbox that you probably might have missing. All right. Now, let's come to making folders. As a programmer or anyone who does some basic programming, anytime you write a set of instructions in an editor and you save them, because you would want to come back to them in future, you can always create a folder. Normally, when you install MATLAB for the first time, just 1 second. When you install MATLAB, you would normally have a folder within your documents that is named MATLAB. Let me see if I can show you mine. So you see the folder within my documents that is named MATLAB. Now within this folder, I can save anything I do in MATLAB here, so that in future, if I need to use any of them, I can just browse and open them. And then it will also give me the opportunity to have my files organized. So I don't have to be going to look for my files or my MATLAB files when I need them and I can't remember where I have saved them. So once I have done that, assuming I want to open any file, I just select open. And then all I do is to go to my documents, go to my MATLAB folder, and then voila. If it is this file I want to open, once I click on it, it will open within the editor for me. Please, do you understand?
Yes, sir.
All right.
Yes, sir.
So that is it with the folders. So you use folders to keep your programs organized. And to make a new folder, you can browse next to the file path, click on make new folder, and change the name as you want. But you can also create a folder specifically at a certain location on your computer that you feel you might need as time goes on. So take note of that, okay? Now, yes, Michael.
Hello, sir. Please, my question
Yes.
is, when you save your MATLAB, the document that it goes, is it means that whenever you are looking for a MATLAB folder that you have worked on, you go to that place, you find it?
What I'm saying is that in order to keep all my files within MATLAB properly organized, I would normally, or you should normally, create a folder. But when you install MATLAB, MATLAB will automatically create a folder in your documents and the name would be MATLAB.
Okay, sir.
What you can do is that anytime you write a program or you do anything in MATLAB and you need to save it, browse to that location and save it there. So that in future, if you need that file, you can go there and open it. Are you clear?
Yes, sir. So, sir, okay, that means that if you do not save it, it will be there.
No, you have to save it there.
Okay, sir.
if you work on your computer and you don't save something, you lose it, right?
Yes, sir.
So in order for you to keep it in that folder, you would need to save it within that folder.
Okay, sir.
All right. Let's move on. Just 1 second. All right. So the next thing we'll look at is help and doc or docs command. Now within MATLAB, a help function is one of the most important commands within MATLAB when, as a student, you are trying to understand or learn how to use MATLAB. Now, that help command is embedded into MATLAB to help you understand any other command within MATLAB. So when you want to get information on how to use a function, you precede that function with help. And normally you do this within the command window. So let's take an example here. This is my MATLAB command window. I want to understand how to use the function sine. Okay, so when I type help sine, it returns some information. Sine of argument in radians. Sine into bracket x, or sine x, is the sine of the elements of what? X. See also a sine or sine d. Other functions named sine. Reference page in help browser. Now, when you come back to this document here, we say that the help gets info on how to use what? A function. It lists the related functions that you would need and how to use them. Now, to even get a nicer version of the help with examples and easy to read descriptions, we use the doc command. So with the doc command, this will open a help window for you in MATLAB. So take a look at this. When I type doc sine, or even when you look at the description reference page in help browser, you see doc sine. But for want of demonstration, let's type doc sine and enter. You see that my MATLAB is currently busy. It is trying to open a reference material on same for us. So you would see it has given us a documentation on sine. It goes to talk about what the sine is. It also gives the syntax or how to write the sine within MATLAB. It also gives the description, and then it also gives us some examples. So when you take this example, for instance, where it says plot the sine function over the domain negative x less or equal to x less or equal to pi, it means that you have to define the variable x and have negative pi to what? Pi, with an interval of 0.01, and then plot x against sine x, and that gives us a graph like this. So this is an example. If you use the doc sine, it gives you a document that gives you examples on how to use the function in particular that you are applying the doc to. Okay, It also has the input argument section, and it also has the output argument section. And then you would also find more information about how to use the sign or information on sign. Okay, so this is basically how we use the doc sign or the doc function. Are we clear here?
Yes, sir.
All right. So then let's make progress. Now, to search for a function, you can also do that by specifying some keywords where you can use doc search. So doc search sign, trigonometry would give you information on that. Let's give it a try. So we have here doc search sign trigonometry. Let's be sure what we have in there. Trigonometric. Okay, so let's see. So you see this also opens a host of information on that particular topic for you in MATLAB, where you can reference and also learn a lot of things. One thing I always tell my students is that when I needed to learn MATLAB when I was in the university, I remember this lecturer of mine who introduced me to MATLAB, Dr. Fum. He's a lecturer in K University now. He needed me to do something for him on MATLAB or using MATLAB. But he didn't have the luxury of teaching me how to use MATLAB because he was a very busy person then. All he did was to hand me a textbook on MATLAB for engineers, and then gave me 1 week to read that book and do his work for him. And that is how I learned MATLAB on my own. So MATLAB, a lot of the things you would learn, you would have to explore and understand them by yourself. That would make it even stick better with you. I am not saying I won't teach. I would teach you guys, but I may not go into details as you would have done if you explored MATLAB further. Okay, so take note of that. So let's make progress. Now, we also have the script. When I started, I have been talking about the script, the editor, the script, the editor. Now, the script is basically a collection of what commands that are executed in a sequence. Okay. Now, we would write the script within or in the MATLAB editor. And our script would always be saved as something we call M files. That is, it has the M or the .m extension. So to create a script file, the easiest way to do that, or the easiest way to create a script file, is for you to go to your MATLAB. So the gentleman who asked me that they cannot see their editor, when you look at my window now, you cannot see my editor, right?
Yes, sir.
All right, it's because I have closed all my scripts. So if I need a new script, or if I need to start a new script, all I need to do is to select what? new script or use the shortcut Control N. So once I click on new script, it opens an untitled editor for me. Please, do you see that?
Yes, sir, we can see.
And this is where we would do all our typing of commands to be executed in MATLAB. Okay, so that is it with the, oh, sorry. Where's MATLAB? So that is the script file. Now, let's look at how to save such a file. Assuming I want to save this file, once I click on save, it will ask me to name it or give it a name. I can give it Antonio. But one thing you should always understand is that anytime you are writing a script file, ensure that the name you are giving to the file is not contained within the file. It's not a good programming practice. In some cases, it can cause your program not to run. Okay, so once I have given it Antonio, you will see that save as type. You see MATLAB code.m. So that will basically become the extension. Where am I going to save my file? I am now going to look for my MATLAB folder, which is here, which already has some MATLAB files, and then I would go ahead to save it. And once I do that, the name changes in the editor to what? Antonio.m. So we call this, even though we call it a script file, we also call it what? An M file, a MATLAB file. Yes, Philip. Philip, we are listening. You raised your hand.
Yes, I said, please, how to save it, the file and come back again. I did not get it correct. Please.
So if I am saving, I would normally, because I have saved it already, let's create a new script file. So when I click on the plus sign here, it gives me an untitled script file. So I just select on save. It will open a command window, a window like this for me. Whatever name I want to give to the file, I can give it to the file. Let's say Philip. And then the save as type will automatically be assigned as a .m file. But because I have a folder in my documents that I have named MATLAB, I want to save my file within that folder so that when I need it, I can go and open it again. So when I save Philip, Philip goes into that file, and then you see my editor has what? Philip.m. Now let me go back to that folder, which is what? The MATLAB folder. Do you see Antonio and Philip here?
Yes, sir.
So that is how you save your file, okay?
Okay.
Yes, sir.
All right. So let's make some progress. Safu Rutherford.
Yeah, hello sir. Please, those who are using MATLAB online.
We cannot hear you.
Hello sir. Sir.
Yeah, kindly speak louder. It's as though you are speaking from far away.
Oh, okay, sir. I was asking that those using MATLAB online, I was asking, can you save it onto your device or to be only be saved onto the cloud?
You can save it onto your device as well. When you are done, there is the option to download it.
Oh, okay, Okay.
So explore that very well. You would find the option to download whatever you have done.
All right, sir. Thank you.
Mm. If it's difficult for you to do, what you can do is that when you're done, you can copy the instructions into a Word document, and later on, when you have a MATLAB installed, you use it. That is one other trick you can use. All right, so let's make progress then. So let's go back to our material. So that is it about script, okay? The next thing is comments. Now within MATLAB and in programming or programming in general, it is very essential that you use what we call comments. Now, comments are part of any MATLAB code which is not executable. So let's journey with me briefly. Let's look for a MATLAB code and see something. So just by the way, one other thing you should always put on your sleeves is that anytime you are doing anything with MATLAB, or anytime you are working with MATLAB or you have a problem to solve and you don't seem to know what to do or what to write, there is that option to just go to MathWorks. There is a whole community in MathWorks where you can get codes or sample codes, and then you get idea on whatever you want to do. Okay, so look at this set of instructions here. I don't know if you can see properly, but let me zoom my screen so you can at least see what I'm talking about. So within this code here, this is a code for amplitude modulation, okay? So you would see that at the beginning of the code, there is a percentage sign with a certain description, tutorial on amplitude modulation. Now, that is basically a comment. That is what we call it in MATLAB, a comment, where anytime you see the percentage sign, anything that follows the percentage sign immediately without any spacing becomes a comment, and that is not executable within MATLAB. So when you go through this code, for instance, you see CLC is just to help clear any other window, figures and all that, close them and clear everything. That is normally at the beginning of every MATLAB code, so that a previous script that you might have run would not interfere with the current one you are trying to run. So look at it. From there, the next section also has what? A comment, which says define amplitude modulation index. So it goes with the command DISP, which is display, which means that anything you see in this bracket in the inverted commas will be displayed within the command window. Okay. So you see anything that follows the percentage sign is now deemed as what? A comment. Now let me copy this. Let me just copy this code into our MATLAB and see if, just 1 second. So I copy this into our editor here, and then I paste it here. So after pasting it here, you see the entire code from the beginning to the end. And a comment is also used to tell us that the code has what, or the script has ended. Okay. So if I have any line within this code that I don't want to execute, when I put a percentage sign in front of it, it all turns green and it will not execute. So for instance, subplot 311, I decide to put a percentage sign in front of it. It turns to what? A comment or a note. So there is no way that would ever execute. Please, do you understand what I'm doing?
Yes, sir.
Yes, sir.
All right.
No, sir.
Okay. So let's make progress then. So
The screen is not that clear.
the screen is not clear. It's your internet, oh.
It's clear, sir.
If it's not clear at your end, it means your internet connectivity is not very strong. That is why. But sorry about that. I am recording this, so when I'm done, I'll try and download it and share it with you guys. So when you read from this slide, what I have just explained, the slide will give you more information, which says comment. Anything following a percentage sign is interpreted as what? A comment. The first contiguous comment becomes the script help file. That is, the first line at the beginning becomes more like a description to that file, okay? You are being advised to comment thoroughly anytime you are writing a script file to avoid wasting time later on when you have to come back to the same code. Assuming you have to write about 100 lines of codes and then you don't put comments anywhere. And then after some few months, you come back to the code. Trying to even understand what you wrote yourself becomes what? A bit challenging. Okay? So note that scripts are somewhat static with no what? Explicit input and output. All variables created or modified in a script retain their values after script execution. So kindly note all these. Now, this is an exercise for you to do. Make a script with the name Hello World. When run, the script should follow the following text. Hello World, I am going to learn MATLAB. Display Hello World. Hint, use DISP to display strings. Strings are written between the single quotes. Example, this is a string. So who can tell us what we would ideally need to write to display that and how we write it? Any idea? At least having seen that example of a script file that I posted just a few minutes ago. Yes, Prince. Hello, Prince.
Hello, sir.
Yes.
Yes, sir. Yeah, it will follow this format: DISP bracket open.
So DISP
hold.
bracket open.
Then we introduce the hold. Then we
We
type
introduce
hello world.
what?
We will hold it by introducing the quotation mark.
Okay.
The quote mark. Then we type hello world. We type exactly what we are trying to type. Then we close it with the quotation mark and end it with the bracket.
Okay. Like this. Can you see
Yes,
my
sir.
screen?
Yes, sir. Yeah, I can see it.
Okay. So you mean if we run this, we should see hello world within the window, right?
Yes, sir.
Okay. So when I run this, you see hello world in the command window.
Yes, sir.
Do you see that?
Yes, sir.
All right. So that is basically the way to go about it. You can also add the other one. You see there were two sets of instructions. It says, oh, sorry, what did I just do? I am learning what? MATLAB. So when I run this, I'll get hello world. I am learning MATLAB. Okay. So that is it with that. Okay. So that is it with that example we just saw there. Now, variable types in MATLAB. Omari Samuel, if you are not following us, you can unmute yourself. You can mute yourself, okay? MATLAB is a weakly typed language, which seeks to say that there is no need to initialize variables, okay? MATLAB supports various data types or types of variables. That is the most popular one, which is for instance, 3.84, which is basically a float, okay? A 64-bit double. It also supports characters like alphabets, okay? And one thing you should know or you should understand is that MATLAB would always, or most of the variables you use in MATLAB would be vectors, matrices, doubles, or characters, okay? So you would have them supported as well by complex symbolic symbols, 16-bit and then 8-bit characters as well. Okay, so that these are basically the data types or the types of variables. Now, to create a variable in MATLAB, you simply assign a value to a name. Okay, for instance, my number variable equals to 3.14. My string variable equals to hello world. Now let's look at some variable rules or variable name rules within MATLAB. First character must be a letter. Take note of that. After that, any combination of numbers, letters, and underscore is acceptable. Also know that the names are case sensitive. Example, my num is different than variable 1. So when you are using any variable within MATLAB, make sure that you are consistent with how the variable is defined throughout the code. Let's look at something within can you see the MATLAB I have just opened?
Yes, sir.
Yes, sir.
Okay, so here, look at this code we got for amplitude modulation. Let's start from the beginning and then see something. You see that m has been defined here as a variable, and 1 is assigned to this variable m. When you go through the code, you will see that wherever the m has been quoted in small letters, it is the same thing that has been quoted here. Anywhere within the code where the m needs to be used, that variable m needs to be used, you will see that it is what? Still m. If you change this to capital M and it is run, it is not the same as this variable. So anytime you are writing your codes, you have to take note of that. If you write your variable in a small case or in small letters, make sure you are consistent with that same declaration in the entire script. Okay, so that is it for variables or naming of variables. Okay, now there are some built-in variables in MATLAB. These built-in variables don't use these names for anything else. So I, J can be used to indicate complex numbers. Pi has the value already of 3.141 within it. So when you look at this code here, you see that here, instead of writing 3.14 something for pi, you see that pi hasn't been defined anywhere as a variable, but it is already known within MATLAB as a variable. So you just use pi straight ahead. Okay, so that is those variables that are already built in. Then ANS stores the results of what? The last unassigned value. It is an inbuilt variable in MATLAB already, so you don't need to use it or assign any variable to it any longer anytime you are writing a MATLAB code. It is just similar to what we term as reserved words or keywords in C programming, where those words cannot be used as what? Variables. Then we have the infinites, and then we have not a number. Okay? All right. So kindly take note of that. Yes, Desmond?
Sir, please, you say the variables are built in. So
Not
does it mean
all
that if I enter
variables.
the value?
Not all variables are built in. These
Okay,
variables you see
those on
here,
the screen right now.
yes, they are
Does it mean
built
if
in
I enter
variables.
1.143, the value of pi, will it automatically change to pi, or I need to bring the pi?
Come again.
I said, if I type the values of pi, will the system automatically change it to pi, or like the value is going to be there? Or is there any
Okay.
way you can bring the variable without entering the value?
Yes, I just showed you an example here. You see pi has been used here without typing the value for pi. Do you see that?
Yes.
So that is how we go about it. You just type the variable without typing its value. So for instance,
Okay.
assuming I come into my command window and I decide to type pi, pi will return an answer of what? 3.1416. So you see ANS, which is an unassigned variable. The last unassigned is what? 3.1416. Do you see that?
Yes, sir.
Are you okay now?
Yes, I'm okay. Thank you.
All right. So that is basically how to go about these variables. Now, we also need to look at scalars. Okay. You can have a variable giving a value explicitly. That is a equals to what? 10. So for instance, when we come to our command window and I say a equals to 10, and I enter, you will see that in my workspace, a has been assigned to what? 10. And this is basically just a 1 by 1 double. It's a scalar, okay? All right. Or in some cases, since a has already been defined, you could have a being used again with its value already assigned. So you see here, or as a function of explicit values and existing variables, C can become 1.3 times 45 minus 2 times A, because A is already what? Defined. Now, one thing you should also understand in MATLAB is that anytime you are doing anything in MATLAB and you don't want the output to come out, you suppress the output with a semicolon. So for instance, here we have A to be 10. We want to say that C equals to, let's say, 5 times A. Once I do this, you see it gives me an output of 50. But I can similarly type the same thing and terminate it with a semicolon. When I enter, the output will not come. Please, do you understand?
Yes, sir.
All right. So within the command window and even within the editor, when you look at the codes here within this editor, you would see that almost all the instructions or all the commands that have been typed here have semicolon at the end of them. And that is what would make it not display when you run the code. So you will not see the outputs of the variables unless you test the outputs in the command window. So kindly take note of that. Then we also have arrays. Like other programming languages, arrays are important or an important part of MATLAB. We have two types of arrays in MATLAB. That is matrix of numbers. Either they are double or complex numbers. Then we also have cell array of objects. That is where you are looking at advanced data structures, okay? So that is it. And then we also have row vector, where when you want to generate a row vector, you have each and every element of the vector being separated by a comma or space, okay? And then all these would normally be within a square bracket. So let's take, for example, let's generate a row vector of so let's say we want to generate a row vector let's say our row vector is row equals to square bracket, 1, 1.1, 2, 3, 4, semicolon. Okay, so once we type this, we get a row vector with these details. And then when you come to your workspace, you would see something interesting. Okay. So you see, when I select that workspace, it gives me what? A 1x5 double. Please, do you see that?
Yes, sir.
Yes,
So it's basically a 1x5 what? Matrix. Row, sorry, a 1x5 row vector, okay? So that is how row vectors are generated, okay? All right. Then we also have column vectors. Now, the only difference here is that instead of generating or separating them with spaces or commas, here we use what? Semicolon. So look at this. The same thing we just generated, I am going to generate it with what? Semicolons. And this would tend to a column vector instead of what? A row vector. Please, do you see that?
Yes, sir.
Yes, sir.
Now, assuming I transpose, so with the first one, which is the row vector, assuming I say B equals to row transpose, what do you think will happen? Any idea? Any idea? So look at something. So I'm now assigning the elements of, okay, yes, Prince, what will happen?
It will print the variables presented in the form of row.
Okay, let's test it and see if indeed you are right. So at the end of the day, you see that my variables have become a column. My vector, which used to be a row, has become a column vector now. Have you seen the drift?
Yes.
Yes.
So you see that row, which initially was a row vector separated by spaces, when I do b equals to row with an inverted comma, you would see that it changes from a row vector to a column vector. So it means when you want to change a row vector to a column vector, you can use what? The complement or the transpose of that to find or to convert it. Similarly, this is now a column vector. So let's say C equals to B transpose. Let's see what we'll get. You see now it turns it to a row vector. So kindly add this to the tips you are learning, okay? Now, size and length. You can tell the difference between a row and a column by looking in the workspace, which I initially showed you, displaying the variable in the command window, which we have done severally, and also using the size function. So the size function would normally tell you how many, the size of whatever variable you have, and then the length will also tell you its length. So when you use size, for instance, size row, it will tell you that the row is what? So here, let's try and see. So what is the size? Size of row? It says what? It's a 1×4 row vector. Okay. What next are we supposed to look at? We are asked to look at the length of row. Just 1 second. So here, let's say the length. This tells us that the length is what? We have 5 elements within that row. Similarly, we could do that for the column here. Okay, so kindly take note of that. So that is how to use the row, sorry, the size and then the length functions. Okay, all right, with these examples here. Now, make matrices like vectors, element by element. So if we want to generate a matrix like we have here, like we have in A, we can generate that matrix. For instance, like we have here, we can generate this matrix by using this command you see here. So let's go back to this and say A equals to 1, 2, semicolon, 3, 4. Then we close this, enter. You see, we now have a matrix, a 2×2 matrix.
Yes,
and
sir.
again, when you go to when you double click in the workspace, it tells you what? It's a 2×2 double, okay? All right, so let's move on. So we've been able to generate that. Now, by concatenating vectors or matrix dimensions, okay? So you can have A equals to 1, that B equals to this, C equals to that. This will give you the first one. A and B would give you row vectors. C would give you a column vector. D would also give you a column vector. E would give you a row vector. Okay. Then you have F, which will give you a combination of what? Vectors. Okay. Then we also have the string where you have hello, I am John, which is basically a string. Okay. Where we call them character vectors. Okay. So basically, that is it with the so save as, or use save to save variables to a file. So here you can use, as you see here, to save and also load your files. Okay. So take note of this. So this is an exercise I would want you to do on your own. Get and save the current date and time. So you create a variable start using the function clock. What is the size of the start? Is it a row or column? What does start contains? You see help, clock, and then you would understand how to use it. Convert the vector starting to a string. Use the function date start and name the new variable start string. Save start and start string into a mat file and name, or a mat file named start time. Okay, so try your hands on this example, and in our next class we would come back to it before we begin the next class. There is also another exercise here which I would need you to try your hands on. Now let's look at some basic scalar operations within MATLAB. For instance, arithmetic operations. We have addition, subtraction, division, multiplication, etc. Okay, so within MATLAB, if we want to do or perform any arithmetic operation, let's take, for instance, we say A equals to 2 and B equals to 3. What would be C if C equals to A plus B? That is giving us 5. We can also do D equals to A divided by B, and that will give us a value for C, a value for D when we do division. We can also have E equals to B minus A, which will give us a value for subtraction. Okay, so take note of that. And then also, when we come back here for exponentiation, let's take, for instance, 4 raised to the power 2. What does it mean if we have 4 to the power 2? So let's take 4. Where is my exponential? Let me see if I can find it on my keyboard. Okay, to the power 2. This gives us 16. It basically means 4 times 4, right? So 2 to the power 2 is what? 4. So kindly take note of how these operations are performed within MATLAB. Then you can also do complicated expressions by using what? Parentheses, okay? So you take note of that. Then we also have some built-in functions, okay? So MATLAB has an enormous library of built-in functions. You can call some of these functions using parentheses or passing parameters to this function. So for instance, square root into bracket 2, okay? Log to the base 2. We also have log to the base 10. You have cos, tan, exponential, round, floor, ceiling, and all that, absolute, etc. So similarly, if you don't really understand how to use these commands or functions, you can just type help followed by the function. And like I taught you earlier, you would be able to generate information on that. Okay? All right. Transpose is what I looked at when I was converting the row vector into a column vector. So the transpose operator turns a column vector into a row vector and vice versa. Okay? So take note of that. So let's look at some addition and subtraction of elements here. So similarly, the way we do, someone's microphone is on and it keeps echoing. The same way we do addition and subtraction normally, it's the same way it is done in MATLAB. So it is element wise, okay? And you cannot do addition and subtraction unless the sizes are the same. So when you take this, for instance, 12, 3, 32, 11, and then 2, 11, 30, 32. If we need to do any addition here, it is element by element. So 12 plus 2, 3 plus 11, giving you 14. 32 plus minus 30, which will become 32 minus 30, which will give us 2. Minus 11 plus 32 becomes what? 21. Similarly, you have the same thing for what? The subtraction, where you have 12 minus 3, 1 minus minus 1, which becomes definitely a plus, 10 minus 13, which becomes minus 23, and then 0 minus 33, okay? So that is what it is. So addition and subtraction, you can do row plus column. You use the transpose to make the size compactable, and then you can do your addition. Okay? All right. Then we have element-wise functions as well. And then we also have some operators. So multiplication can be done in a standard way or element-wise. So for standard multiplication, you have the asterisk, okay? And then you also have the standard exponentiation, and we also have the left and right division. Okay, so you take note of how all these can be done in MATLAB. Now, we also have something we call automatic initialization. That is to initialize a vector. It could be a vector of ones, it could be a vector of zeros, or random numbers. So if I need a vector of ones from 1 to 10, okay, what it basically means is that here I am telling my MATLAB generate p equals to ones into bracket 1 comma 10, and what it will do is that it will generate ones numbering 1 2 3 4 5 6 7 8 9 10 for me. If I say zeros, p equals to zeros into bracket 1 comma 10, it will generate 10 zeros for me. If I say p equals to rand 1 comma 10, it will also generate random values for me. Okay, all right, so this are also some automatic initializations that can be used or explored in MATLAB. So take note of that. So we have the zeros, the ones, the rand, and then we have the none. Okay. All right. We also have the line space that is used to initialize a line vector of values. Okay. So for this one, what it means basically is that you start the vector from 0 and it will end at 10, but it will have values of what? 5 values. So for instance here, when we say p equals to line space zero comma 10 comma 5, what we are basically saying is that it should generate values from 0 to 10, and the value should be a number or should be numbering 5. So 1 2 3 4 5. Okay, so kindly take note of that. And then we can also create colon operators using this colon. So you can start with 0 colon 2, which means is that the next value will be 0 plus 2. The next one will be 2 plus 2. The next one will be 4 plus 2 till you get to the value of 10. And then here, where you have c equals to 1 is to 5, the increment is not specified. So at the end of the day, you would get the increment to be 1, which is very default. Okay, all right. And then vector indexing, just as we index numbers. Similarly, the position of these elements of a vector are also looked at, or you can also look at that within MATLAB. Okay, all right. Similarly, we also have matrix indexing. Then you can move on to some advanced indexing methods. And then we come to plotting. And here we will do just an example of how to plot in MATLAB. Now, let's take, for example, we have x, and x line space 0, 4 times pi to 10. What this basically means is that CLC x equals to line space into bracket 0, comma 4 times pi, comma 10. Okay, so here if I put a semicolon, the output will not show, but if I type x here, I can get the values. Okay, so we are generating 10 values from 0 with intervals of what? 4 times pi. Okay, and then we say that y equals to sine x. So y equals to sine of x. And this also gives us some values. Now we are saying that let's plot y. And once we do that, it should give us a plot of the y values. So we get a graph plotting the values of y. Okay. All right. We can also do plot into bracket x comma y and see what we get. It's the same thing. Okay. So that is basically a simple introduction to how you can do plotting in MATLAB. So this brings us to the end of lecture 1 on unit 2 and 3. That is the basics of MATLAB. So in our next lecture, here, before we end, you realize that the first plot we didn't have a very smooth curve. But if we are to change the last value to 1000, it means it will give us a lot of points to be able to plot to get a good sine curve, okay, which you can try your hands on. So similarly, like I was saying earlier, according to our outline for unit 2 and 3, we are supposed to look at MATLAB basics, which we have done in this class or in this lecture. The next thing we'll look at is visualization and programming. And then we'll move on to solving equations, curve fitting, and numerical techniques, and then advanced methods. It is my hope that we can finish this before the end of next week. So within this week, I would request for another time where we shall look at visualization and programming. And then next week, we will look at solving equations, curve fitting, numerical techniques, and advanced methods before we write mid-semester exams. So kindly take note of that. And be ready when I request for some 2 hours for this class. So thank you so much for joining this afternoon session. Is there any questions so far? If there is none, then we can draw this class or this session to a close. So if there is any question, feel free to ask. Michael.
Sir, please, my question is about the comment.
Your
When you were
question is
talking about
about
the comment.
Uh-huh.
In your slides, the first point was when you start with a percentage sign.
Mm-hmm.
Yeah, it looks like a comment. It becomes a comment.
Okay.
But your last but one point, you said with 2%. So
Uh-huh.
I want to ask that with 2%, what happens to the text?
It is still a comment. Nothing
Okay, sir.
changes.
Okay, sir.
Once there is a percentage immediately followed by some notes, it all becomes a comment. Anything that follows it would not be executed.
Okay, sir.
All right. Yes, Safo.
Okay, sir. During the program or the course we copied from the MATLAB, you could
Mm-hmm.
see when he was writing the code, he brought the percentage sign. After then, he was typing the XXX before typing the words he wanted to use. I wanted to know the importance of those XXXX on there.
Okay, so what he did here basically is that I hope you guys have done amplitude modulation in Telecom 1.
Yes, sir.
Okay, so you notice that in amplitude modulation, you need modulation index, right? Within
Yes,
the
sir.
amplitude modulation equation, you would need your modulation index or the amplitude of the modulating signal as well as the amplitude of the carrier signal. And again, you need the modulating signal itself and you need the carrier signal itself before you do the modulation. So what he did here basically, or what has been done in this code here, is that he has tried to put the code in sections. So for every section, he puts a comment at the top and gives it a title. So those XXX you see there don't really have any execution function within the code. It only goes to explain what that set of instructions below are doing. So you see that when you move from there, here define AM modulation index, then there are some instructions, display m equals to 1 if blah blah blah, error blah blah blah, end. Modulating signal, AM equals to blah 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 and all that, till it gets to what? Figure so and so, does the plotting and all that. Then it comes to the next section. So the XXX doesn't really have any execution function within the code, except that it is used to explain the code or that section of the code. Okay. All right. Any other question? Okay, if there is no further question, then I would want to bring today's class to an end. And then we would meet again in the course of the week. It can be on Thursday or on Friday. So kindly take note of that. Okay?
Okay, sir.
All right. Thank you so much for your time and have a wonderful day.